Hello everybody. So welcome to this is our week 4 video and assignment. It's actually going to be posted in week 5, but sorry about that. I got backed up with grades coming up with progress reports due. Anyways, we're going to be starting chapter 2 today, and chapter 2's title is lines and angles. So we're going to be learning about lines, and then after we learn about lines, we'll learn about angles, what they are, what their definition is, and how to use them, and how to properly label them. Okay, so today we're going to be mostly talking about lines and objects and like how lines will form shapes. And yeah, so we'll be talking about how lines will form many different types of shapes and like what that means for them and so forth. But for the sake of this video, we're going to have to start with something that is a little bit less than a line, that kind of makes up what a line is. Now, what that is a point. So let's start with the most basic form, most basic object in geometry, which is a point. So I'm going to go ahead and label it. Now, some people argue whether or not there is a definition of a point, or whether there's not a definition of a point, that it's just too small to make a formal definition. I'm actually going to give it a definition so that we can define what it is. And what I'm going to call it is a dimensionless object. And this is what it is right here. It is a dimensionless object. Now, how do we properly label a point? And the way that we're going to properly label is like this. I'm going to draw it as an example. And it's just going to be a little dot, and it's going to be a capital letter. Make it a little bit more visible. So capital letters properly label points. Okay, so that's how you properly label a point, is that it's denoted by a capital letter. Now, that'll be important later whenever we start labeling more complex things like triangles or, I don't know, a pentagon or something like that. We're going to have to properly label the points in the pentagon or in the triangle or on a line. So from here, this is a dimensionless object, so that means it has no dimension. So what is a dimension? So a dimension, I'm not going to label it, I'm not going to write it down as a definition, but a dimension is what defines how it makes up in space. So a dimensionless point, like a point, we're not going to see it in space. It needs something else for us to be able to label it. So let's say that we have 2 points here. So now we've got 2 points. I'm going to label them A and B. And I've got something that connects these 2 points. So these 2 points will now be connected somehow. This is now called a line. Technically, this is a line segment. So a line extends in forever. A line extends forever. So let's go ahead and give it a definition. Let's say is a series of points that extend in two directions let me clear that up. Forever. So a line is like, so if I was to stick my arms out, this would be like a representation of, like a metaphor kind of a line, meaning that it extends forever. In this way, it's a series of points. So if we took a point and then another point touching it, another point touching it, another point touching it, and extend it forever, then that's what a line is. Now a line segment is exactly what it is, like what it sounds like. Is a segment. So a segment of a line. And then I'll go ahead and give you an example. And we'll label this A and B. Now, I'm going to get into some labeling here. I'm going to label them in red. So this is how you properly name a line. So this line's name is like this. You draw A, capital A, and then capital B, and then you draw a line above it. Just like that. Now notice up here there's arrows pointing in either direction. Now how would we properly name a line segment? Very similar. You list the 2 points that make up the line segment, and then since it's a line segment, we draw a line segment above it. Just like that. So that's what makes up a line segment. Well, that's how you properly name a line segment. All right, so from here, now we're going to talk about how many dimensions a line has. So, let's write this in yellow. How many dimensions does a line segment have? So we go up to the top. So that if like we were going to say dimensionless, it's the same as saying 0 dimensions. A point has 0 dimensions, and now we've taken 2 0-dimensional objects and connected them. And that actually creates a dimension. So how many dimensions does a line segment have? Well, 1 dimension. I think that's how you spell it. Maybe not. But so from here, let's create hold on. Let me draw. This is 2 line segments. And like we did before, so up here we drew 2 points, which were 0-dimensional objects, and we connected them. So now we have 2 1-dimensional objects, and we're going to connect them. And this actually forms a plane. Well, this isn't a plane. A plane is shaded throughout and all the points is included. Okay, so this isn't a plane. So this is a shape. It's pretty much what it is. This is a 4-sided shape. So we're just going to label this as, I'm just going to write up above it, how many dimensions does the following object have? And the answer is, well, we have a length, and we have a width, and 2 dimensions. Okay, so if we're looking at the dimensions of this shape, so this is a four-sided polygon, but it's not a regular polygon because I didn't draw it with equal, but we'll get into that later. This is a four-sided polygon, but what I want you to take from this is that there are 2 dimensions here. There is a length and a width. So some people would look at a triangle and think, well, there's 3 sides to a triangle. How many dimensions does a triangle have? Well, a triangle has 2 dimensions because it's made up of 2 dimensions. I have a base and a height. You know, those are our 2 dimensions. Now, how do we use those base and height to find the area or the perimeter? You know, it's a little bit different than like a square, a rectangle, a rhombus, but they are in 2 dimensions. So like that's how they're made up. So that's why this is a 2-dimensional object. We have 2 one-dimensional objects that are connected. So down here, let's draw let's draw 2 two-dimensional objects and connect them. So now we have 2 two-dimensional objects and we connected them. So how many dimensions does this have? Let's copy the one before so that I can copy, paste. How many dimensions does the following object have? Well, let's look. I'm going to change the color to red. Here is our 2 one-dimensional, that's our 2 two-dimensional objects there. Now they're connected with this here. That's how they're connected. And it's pushed back. So you have a 2-dimensional object, another 2-dimensional object, and then they're connected. So what does that create? Well, it creates a box or like a rectangular prism or whatever you want to call it. But how many dimensions does it have? Well, it has a length, some depth, and a height. Let's make that more of an L. Length, depth, and then a height. So this has 3 dimensions. I hope you see a pattern here. So here's going to be the question from the video is what would a 4-dimension object look like? And I'm actually going to put this as your first question on your assignment so there won't be any confusion on what to turn it in and stuff like that. But this is going to be from the video, and I'll put on the assignments from the video. But what does a 4-dimensional object look like? We've just went through a 0-dimensional object, a dimensionless object. We went through a 1-dimensional object. We have now gone through a 2-dimensional object. and a three-dimensional object right here. Now, what would a four-dimensional object look like? Okay, so I do have like a little rant really quickly. Whenever people talk about going into another dimension and things like that, like so he just crossed over into another dimension, that bothers me because the dimension is what they use to cross into another universe or another like plane or object. So like over here, if I was a two-dimensional object and I was going to cross to another two-dimensional object, I would have to go through the third dimension to get there. See what I mean? Like I'd have to travel that third dimension. There's no third dimension is what I'm saying. Is I have to cross over. I don't know, it's a rant. Whenever people talk about dimensions on science fiction and stuff like that, they don't know what you're talking about. Anyways, but so from here we're going to talk about, I'm going to draw a definition of a plane. And by plane I don't mean something that flies in the sky. And a plane is a series of points that extend in, we'll say, three directions. So here's an example of a plane so this would be a plane, so it's like it's a two-dimensional object, so it has a length and a width, but all of these points in here are concluded. And you properly label a plane with a script letter. We won't ever be dealing with this as far as talking about, we won't ever be finding this. It's just that it's important for you to know what a plane is. So like think about the surface of this table. The surface of this table is a plane. Think of like this whiteboard. Surface of this whiteboard is a plane. So let's go from here. We're going to talk about collinear. Give you a few definitions and examples. Two or let me write this a little bit more formally. Two or more points that lie on a line are collinear. And here's an example. There we go. So these 2 points, A, B, these 2 points are collinear. And let's say that I have this point over here. I'll call this label point. This is not collinear. So that's what it means to be collinear. It's like if you have 2 points that are on the same line, then they are collinear. Now, this point over here that's not on the same line, they are not collinear. Okay. Let's look at coplanar real quick. So 3 points are required for a plane. So let me, in a hurry. Definition 3 or more points that lie.
Pardon the interruption. I need the following students in the front office at this time: Noah Burton, Chris Crow, Cody Goody, Courtney Hall, Donna Hall, Jason Johnson, Dylan Kirk, Elizabeth Large, Randy Mulkey, Samantha Knoll, and Seth Schaub.
Sorry about that. Three or more points that lie on a plane are coplanar. Okay, so what would that look like? Draw an example. So draw our plane. And I'll label it L. And let's say that we have 3 points on here. 3 points that are lying on this plane, A, B, and C. These points are coplanar. And then let's say that there's a line, or like some squiggly line. Let me draw it a little bit more. That passes through, say there's something that passes through here and this point up here is not on the plane. This would be point D, say not coplanar. Okay, so that's what it means to not be coplanar. It's like if we were on this table and then I was to hold a point right here above the table, this point is not on any, it's not on the same plane as these points that are on this table. So that's what it means to be coplanar. All right, so that's pretty well what I have today. We will be using these definitions throughout the rest of chapter 2. So this is kind of what makes up lines, and we'll be talking about how to use these. Next week we'll be getting into midpoints and bisectors, midpoints and bisectors, and we will be talking about how to measure them from there. And then you'll actually be calculating some measurements of the midpoints and proving some things based on what a bisector is. Okay, so we're going to be starting some proofs next week, and I will be drawing some proofs out for you. And that's all I have today. So thank you for watching. Thank you for your patience, and I'll see you in the next video.